Okay, YouTube, in this video we're going to determine domain and range from the graph of the function. And recall in our first video we talk about the domain values as being the input values for a relation and the range values as being the output values for that given relation. So when we talk about domain and range from the graph, we mean very much the same thing. The domain is the set of inputs, and we find these on the, of course, x-axis. And the range is going to be the set of outputs, in which we'll find those on the y-axis there. So you'll notice that this is actually a pretty good illustration. I wanted to include this in the notes here, but basically we say the domain of this graph would be the set of all x values that are included in these ordered pairs that you see here. So you'll notice that we have closed dots on the end of this graph. And so my favorite part of this is they highlight on the x-axis, it says that this is the interval of values, or at least the input values of which our graph covers. And as far as range values are concerned, the lowest this graph ever goes happens to be at this point right here, and the highest it ever goes is right here. So we say this is the set of range values for our graph, or that interval of values there. And it certainly does include the endpoints again, because we included the endpoints here. They were closed dots. So what I want to do in this video is essentially determine the domain or range for each of these functions or relations that we see over here, and they all happen to be functions. But we'll start with this one right here on letter A. So I noticed that it starts at -2 and has a closed dot. And it kind of goes up here and then bends and then ends here. So because we have closed dots on the endpoints of this interval, we could say that the domain is going to start at -2, including -2, and go up to 1. And we'll just write this in interval notation. As a matter of fact, that is desirable. So we say domain is -2 up to and including 1. And then as far as the range is concerned, we'd say that the lowest this point ever gets on the y-axis, kind of a little crowded here, is 0. And it goes up to a height of 3. And it actually includes this height of 3 because of that closed dot right there. So we say starting at 0, including 0, going up to and including 3. So looking at letter B here, you'll notice, I hope, that this has an open dot on the left side. So when we write the domain this time, we're actually going to write this as having a domain that starts just beyond -3 and then goes up to and includes 2. So our domain in this case would be not including -3, just starting just beyond it and then going up to and including 2. And then our range values here, well, the lowest this graph ever gets in terms of the range, tracing this back over to the y-axis, is 1. And then it goes up to a height of 2. And those are the only output values that it covers on the y-axis. So we would say, oh, actually, this is a little bit of a mistake here, isn't it? We say it didn't reach a height of 1. It reached just beyond it. So this would be an open parenthesis there and then a closed bracket. So we would have starting at just beyond 1 and going up to and including 2. This would be our set of range values here. So looking at letter C, it looks like if we trace this down to the x-axis here, it looks like it would include -2 and go up to but not include 1 because we have an open dot here. So our domain would be starting at -2, going up to and not including 1. And then our range values here, well, the lowest this graph ever gets looks like is a height of 1. It's at its vertex, and it does include that point. So I'm going to say it does include that point. It looks like it gets to a height of 5 also. So this entire interval of values here on the y-axis would be our range. So we say 1 up to and including 5. So now looking at these last two, I do want to make a special note on letters D and E. So starting with letter D, I get a lot of people that write the domain of this one. It looks like it goes to the left forever and ever because of this arrow, and then comes up to 4. But if we said what's the interval of values, I sometimes get people that say it starts at and includes 4 and then goes to -infinity, and I'm like, well, understand that this is wrong the way you've written it. And they're like, well, I did use a parenthesis on the infinity, but the thing is this, we read from left to right. So it is always assumed that this value on the left here is less than or to the left of the value that we list on the right if we're going to read from left to right. So the domain of this, certainly if we put this on the x-axis here, we could say is this. It's this set of values here, and I'll just put an arrow on there. But what this would mean is our domain is starting way out at -infinity, going up to and including 4, and we do not include the -infinity. And our range in this case looks like we get to a lowest height of 0 here on the y-axis, and it did have a closed dot right here. So it starts at 0, and then this graph kind of hits all y values above this. So we'd say starting at 0 and going up to +infinity. Make sure we get it in that least to greatest order. So this last one here, E, a little bit tricky for some people, but looking at E, what I want you to understand is that it does, in terms of its domain, start way left at 1 here. Not way left, but it includes 1. But as we go out to the right here, a lot of people say, well, there are gaps in this graph. For every gap that you see here in these middle two gaps, it is picked up by this upper part of the graph right there. Those closed dots actually pass over the x value that this lower portion here missed at 2. So what this means is they kind of fill in the gaps there. The only gap that doesn't get filled in by the next portion of this graph is at 4. So we would say the domain of this would be starting at 1 and including 1 and going up to but not including 4, because there is a gap there at the end. So we would say 1 up to but not including 4. And then our range values here, looks like we only hit range values of 1, 2, and 3. If we were to list all the points on this graph, they only have those as y values. So we would say the range, because it's discrete, that is, it's not an interval of values, but it has gaps in it. We're going to say it's the set of y values, all y values, such that y is explicitly equal to 1, 2, and 3 only. And we are forced to write this in set builder notation this time. Cheers.